that in mind, I'll hand you over to Atlas from BeatDrop.
Hello everyone. My name is Atlas Brosen, and we are Team BeatDrop. Before we begin, I'd like to introduce the rest of the team. That's Alex Evans, Jack Marsden, James Jinks, and Sachin Naranji. And today we are presenting our game, BeatDrop. Next slide, please. BeatDrop is a vertical scroller game where the player must dodge platforms, obstacles, collect power-ups, avoid power downs, and build a high score. During account creation, the player can customize their profile and overall game experience by selecting from 6 different in-game characters to play as, all of which look and feel slightly different to play. If the player scores high enough, they can unlock a variety of achievements across 5 distinct levels that we have playable within the game. Additionally, if the player manages to place a high score, that score is posted to our social feed, where the player can then see their personal scores for each level and compare those scores against a global leaderboard. So now I'd like to hand you over to Jack for the demo.
Hello, thank you. Thanks, Alice. So hi. Hello, my name's Jack, and I'm going to run through the overall design of the game and how certain features were implemented. For our initial sign-up page, we use Firebase authentication, allowing us to use the cloud service to store our user information. We have a level select system. This allows users to cycle through each of our levels with a small preview on each of them, and then the option to play. We decided to design a number of different levels with different themes, with music tracks and sound effects to support each one. We'll play a bit of the audio and then we'll review. Yep, so you can mute that now, thank you. So the main points of the game is to increase your score by collecting stars as you're travelling through the level and avoid obstacles on the way. The player moves along the x-axis while the background infinitely scrolls throughout the level and the obstacles travel upwards, giving the feeling that the player is falling. The stars, the power-ups and the obstacles are relatively similar in design for how they are generated. We wanted to create something of a level generator, meaning that we can implement more complex designs with ease. All of the objects are procedurally generated, meaning each level will be different on each playthrough. Each of the objects are recycled as well, so once they leave the screen, they're destroyed and then recreated below the player. Creating the objects in this way streamlined the process and allowed us to have the ability to create more levels. We also implemented a pause menu. The user can pause the level as well as mute and unmute the current music. And then, as you can see, once we come towards the end of the level, it shows the user's overall score and then also the medals they've achieved for that level. Upon achieving a high score and placing on the global leaderboards, this will then be reflected in our socials page. This shows our most recent events worldwide. Other users are able to see this feed and comment on the post to interact with other users. We use the same card design for each of the pages, keeping the design consistent throughout the web app, whilst also maintaining that nice overall look. Users can interact with others on this feed by leaving messages, congratulating on various things such as achievements or high scores. Okay, and the next thing we'll look at is the profile page. So this allows the user to select their avatar. This reflects both in-game and on the social feed as well. And additionally, you can also check the medals you've achieved for each level on this page. The sprites on the page are static. For the game, we actually had to stitch these together to create a sprite sheet so we could have a full animation on movement within the game. The final thing that we'll look at is our high scores. So you've got the personal high scores, which shows your personal best for each 5 of the levels and the dates that you achieve them. And then very similarly as well, we also have the world records. So this shows the best scores for each level throughout the entirety of the world. And yeah, that's it for the demo. Thank you very much for listening. And I'll hand over to James and he'll talk about our spiking.
Thanks very much, Jack. The first stage of our project and one of the most enjoyable parts was the spiking phase. Developing a game was completely different to anything we'd done on the course previously, so our spiking was very varied. We had to look at a lot of different technology and see what would be suitable. From our initial selections, we were able to rule out other tech based on how compatible it would be on the things we'd decided already, based on our user stories, requirements. We knew from the outset that the social aspect of the game needed to employ a database with user authentication. We knew we could do that with what we've done on the course so far with Express and Postgres, so we could look into cloud services such as AWS DynamoDB and Cognito. or Firebase and authorization and Firestore. For our game engines, we will look, the main two contenders were Pixie.js and Phaser. The game engines worked in quite a specific way that ruled out using certain frameworks for building our web app. Moving to the next slide, I'd like to talk a little bit about our team structure and planning. First thing we did was create an organization on GitHub. In this organization, we made different repos for spiking different technology, something that we could then look back on later and feed back to the rest of the team. We employed Kanban and daily stand-ups for keeping track of our day-to-day activities for each team member. Those aspects of agile methodology were really well suited for the short time frame of the project. It enabled us to minimize our time planning and spend our time testing and coding and playing the game, of course. I'd like to pass on to Alex. Alex is going to talk about what our final choices were for the tech stack.
Thanks very much. After spiking, we weighed up all the user stories from our initial planning stage, and we decided on a tech stack that would allow us to meet the requirements that we'd set out while also delivering a working product in just 8 working days. Can I see the next slide, please? Thanks. For the front end, we chose Phaser.js as our main game framework, and then we chose React as our main front end library. We chose Phaser as it's a really well-supported open source framework, which allows for fast rendering of games on desktop and mobile. Although it was a new framework for us, we felt confident that it would allow us to use all the JavaScript knowledge that we built up during our time on the course. The inbuilt physics system and the community support made building a game in such a short time frame viable. React is a platform that we all really enjoyed using on the course, and it fit with our requirement to make sure the game was accessible and responsive on all different devices. One of the biggest challenges early on was making sure that React and Phaser could be integrated, and working through this as a group and in pair programming was a real confidence builder because it made sure that the structure of our app was really robust before we started making the game. Can you move to the next slide, please? Thank you. For the back end, we were all keen to explore the use of a cloud platform in our project, and after spiking, we decided on Firebase. For our database, although we'd had quite a lot of experience using SQL on the course, we decided that the flexible scope of the project meant we'd benefit from using a non-relational database. This also allowed the flexibility to introduce new features and update our storage model as the project developed. Firebase allowed us to integrate authentication in the app, as well as offering the cloud Firestore, which allowed us to build and edit data in a flexible way. It also had the benefit of being really well supported by documentation, which helped a lot throughout the whole project phase. In our tech choices, we always strive to find a balance between building on our existing skills and our existing experience and integrating new technologies. And overall, our choices really helped to meet the challenges that we'd set out for ourselves during the planning stage. I'm now going to pass it back to Atlas to talk a little bit about our development process.
Yeah, thank you, Alex. As Alex mentioned, making a video game is a very difficult undertaking in just the 8 days of coding we actually had available. As you can imagine, this led to quite a few unique and interesting situations and solutions we had to come up with. Having watched the demo of the game earlier, you might have gotten the impression that the player is actually falling through the level. That's not actually quite true. In fact, the player is actually falling extremely slowly, and it's instead that the background, the various obstacles and collectibles actually flying past the player. We did this by setting negative velocity values to our in-game objects, which kind of mimicked this reverse, almost anti-gravity type scenario. And that's pretty much how we got that effect with the scrolling backgrounds and stuff. It's only by the bottom of the level that we actually increase player gravity to make sure they actually hit the bottom to make it kind of feel satisfying and kind of match the design with like the little parachute and stuff like that. In general, developing a game leads to a lot of tweaking for in terms of tweaking the game for balance and fun, particularly in like early on in development where we were playing with various parameters. We had issues where the platform would absolutely fly past the player and it was impossible to play, or the platform's moving too slow. So just a lot of tweaking and game balancing. But that is one of the benefits of Phaser. It has a ton of different parameters that we can play with, And because of that, we actually got a bunch of additional ideas and designs that we'd love to make use of. And as such, I'd like to pass on to Sachin on the next slide to talk more about some of the future developments we'd love to make to the game.
Thank you, Atlas. Hi everyone, I'm Sachin. And regarding future development, because we wanted BeatDrop to have as much of a social feel to it as possible, something we started by adding a social page, the next requirement we'd look to implement would be a friends list, whereby users could then add each other as friends, and upon navigating to the leaderboard page, then compare their scores against those of their friends. Following this, we would also like to expand the achievement system, as currently we've only got bronze, silver, and gold badges for each level. And I know that we have a list of more interesting achievements available on one of our Discord channels. So I think with the flexibility of sort of NoSQL databases and how we have set up the achievements currently, it's very sort of easily expandable. Something else we're also quite excited about is the possibility of adding multiplayer functionality in some form, either as having multiple users play through the same level together with slightly smaller character sprites, so they could all like fit on a single page, or in kind of a ghost format, whereby when a player plays through a level, their path through that level is recorded. And when another user then comes to play that level, they see their friends play through side by side with their playthrough. Something else, sort of more down the line, I think, in the long term, is that we would like to look at is integrating BeatDrop across more operating systems. While currently there is CSS styling in place to make the game playable on mobile devices through web browsers, during our spiking phase, we confirmed that React projects can be wrapped within a framework called Ionic, previously mentioned by Team Chorus, and then using a package called Capacitor. We could then render native Android and iOS applications from it, and also a native Windows 10 desktop application using a package called Electron. Along with allowing for crossplay between platforms, integrating natively would also open up the possibility of features such as pushing social notifications on Android and iOS devices, for example. However, before proceeding in this direction, I think we would need to evaluate any performance loss stemming from this conversion process. Thank you everyone for listening to our presentation. Has anybody got any questions?